From page 11 on the student workbooklet, just looking at the chord properties. The perpendicular line drawn from the center of a circle to a chord bisects the chord, and the converse theorem is a line drawn from the center of a circle that bisects a chord is perpendicular to the chord. Second theorem here is that equal chords, in other words, if AB equals CD, so equal chords are equidistant from the center of the circle. So if AB equals CD, then means that ON equals OM. And the converse theorem is that if the chords are equal distance from the center of the circle, in other words, if ON equals OM, then AB equals CD. So chords that are equidistant from the center of the circle are equal in length. That's the converse theorem. And the last theorem here is that the product of intercepts of intersecting chords are equal. In other words, AX times XB equals CX times XD. Page 12, just checking your solutions here. Given that XY equals YZ, and this angle here is 54 degrees, you have to find angle XOY. We know that XY is YZ, meaning that OY must be, the angle OYX is 90 degrees, because a line drawn from the center of a circle that bisects a chord is perpendicular to the chord, so we've got a right angle there. Therefore, you can find angle XOY by angle sum of a triangle, and you should get 36 degrees. Now for question 2, we are told that OC is perpendicular to AB, so we now know, and we know that the radius of the circle is 6 and that this chord is 11, because this is a perpendicular drawn from the center of a circle to a chord, it does bisect the chord, so therefore the length CB will be half of what AB is, which is half of 11, which is 5.5 centimeters. And then we can use Pythagoras' theorem to calculate OC. So OC is 2.4 centimeters to 1 decimal place. We're told that the chords are equal in length, that AB equals CD, and so therefore we can say that OE equals OF, and we're told that OF is 2.5 centimeters, and that's because equal chords, those chords are equal, so we start with equal chords are equidistant from the center of a circle. So we know that OE is now 2.5 centimeters, and we have to find the length of FD as well. We know that angle OFD is 90 degrees, that's given. So therefore, OF will bisect CD. So FD is half of CD, so it's half of 4 centimeters, which is 2 centimeters. Reason, the perpendicular from the center of a circle to a chord bisects the chord. So just writing those the correct way around. You know that the line is perpendicular, so you start with that and you say that it bisects the chord. Okay, in question 4, you are told that angle BIO is a right angle, and that angle OHE is also a right angle, and that OGC is a right angle. In other words, and you also know that OI equals OG equals OH. And you know that FE, that whole length is 7 millimeters. You have to find the lengths of AB and CG. Okay. You know that OI, OG, and OH are all perpendiculars. They're all perpendiculars from the center of the circle, but we know that OI equals OH equals OG. So we can now say that AB equals FE equals CD, because those 3 chords are all equidistant from the center of a circle. So chords that are equidistant, we know that those 3 chords are equal distances from the center of the circle. So chords that are equidistant from the center of a circle are equal in length. So we're supposed to find that. So what's the length? FE is 7, so equals 7 millimeters. Okay, and now we know that OG is a perpendicular. Oh, which one are we finding? CG. So because OG is perpendicular to the chord, it will bisect the chord. So CG will be half of 7, which is 3.5 millimeters, because the perpendicular from the center of a circle to a chord bisects the chord. Now with question 5, similar things again. We know that DE is 56, OE is 35. We know that OC is 21. Okay, you have to show that AB equals DE. Now, the only way that AB will equal DE is if OC equals OF. That is the only way that AB will equal DE. Because if those chords are to be equal length, then they must be equidistant from the center of the circle. So we know that FE, for example, so what we're going to do, we need to find this distance. So let's work in this triangle here. So we know that FE is a half of DE, which is a half of 56, so it's 28 millimeters, because we know that this is a perpendicular, because the perpendicular OF from the center of the circle to that chord bisects the chord. Once we know that this is 28 here, millimeters, we can use Pythagoras' theorem to work out OF. So OF squared is that. OF is 21. Well, if OF is 21, it means that chords AB and DE are equidistant from the center of the circle. So therefore AB equals DE equals 56, because chords that are equidistant from the center of a circle are equal in length. Isn't it AE times EB equals DE times EC? Reason? The products of intercepts of intersecting chords, sorry, they're not lines, intersecting chords are equal, and then you can just substitute. Okay, so we've got what have I got? AE 3 times 12 equals 4 times x, so therefore x is 9. Okay, and same with the second one, but you're going to get a quadratic. So AE times EB equals DE times EC. Again, the product of intercepts of intersecting chords are equal. And so we get x times x equals 4 times 7. X squared is 28. X equals, like, plus or minus square root 28, but I'm just going to go square root of 28 as x is greater than 0, which is 2 root 7 if you simplify. Okay, so it's 2 root 7. We know that x is greater than 0 because it's a length. And your last one. Last one, you're actually given the length of AB and you're given the length of EB, so by subtraction you can find the length of AE, which is 9.6 centimeters. Again, product of intercepts of intersecting chords are equal. Okay, and of intersecting chords are equal. And what did you get for your answer, everyone, please? 2.4 centimeters. Okay, end of those 3 theorems. Notice there are 3 chord theorems. Okay, I think it was 3. Isn't it 3? Yep, 3. 3 chord properties. So just try and say, remember, there are 3 of those properties I need to remember.